Professor Dr. N. Gunasekaran, retired senior professor, after serving about 40 years in Electronics and Communication Engineering Department, College of Engineering, Anna University, Chennai. He is presently working as Principal, Pratyusha Institute of Technology and Management, Tiruvallur, Chennai. He has 40 years of teaching experience in the field of electronics and communication engineering. He had visited countries such as USA, UK, Germany and Sri Lanka on various academic activities. He has about 90 research papers to his credit. He has guided 6 PhD scholars and 3 MS program scholars. He has published 10 books and 10 monographs. He has attended 19 short-term courses. He submitted 33 proposals to the Development of Electronics Department. He had purchased equipments to the tune of Rs 150 lakhs for the growth of the department. He has developed many laboratories such as Microwave Lab, Fiber Optical Communication Lab, Laser Communication Lab, Satellite Communication Lab, VHF-UHF Communication Lab, and UG Basic Laboratory. He conducted more than 50 short-term courses, winter schools, summer schools, and faculty development programs. He executed a number of government-funded projects at Anna University. He received Best Project Awards twice for UG projects at state level through Directorate of Technical Education and at national level President of India Award for the project on telephone for physically handicapped persons. He is a member of many professional bodies such as Institution of Electrical and Electronics Engineering, Fellow of Institute of Electronics and Telecommunication Engineering, and Broadcast Engineers Society of India. He is also a life member of Institution Engineering, life member of Indian Society of Technical Education, and life member of Optical Society of India. His current fields of interest are electromagnetic theory, antennas, satellite communication, and fiber optical communication.
Welcome to UGC lecture series in Applied Electronics. This series covers semester 5 paper 10 on antenna and wave propagation. Today we will be discussing some special type of antennas, and later on we will really start entering into the concepts of fields. Now we are slowly bringing in some important technical discussion whereby the real antenna problem will be understood. We have been discussing on different type of antennas up to microwave. Now we discussed about horn antenna and reflector antenna working at microwave frequency. Microwave frequency anything above 1 gigahertz. That is for example, this is a horn antenna functioning at 1 gigahertz above. For example, the frequency band where these are all operating are called J band, X band frequencies, Q band frequencies. Same way, if you talk about the reflector antenna, these are all working again very close to rather C band. See, the terminology is slightly different. C band, KU band, K band, K band. They are called J band, X band. So anyway, don't bother about the frequency band names. Slowly you will get familiar, but you have to. That's no other choice. By the end of the subject discussion, you have to be very familiar with what are the various frequencies. These are all standardized frequency bands. Very standardized frequency bands. Only it's a question of familiarity. You will slowly get into the groove. Now is another type of antennas where the antennas are mounted on the towers. Big towers will be there. For all mobile communication, we have antennas mounted on the towers, and the antennas are also functioning at somewhere in the UHF range, very close to microwave range. And if you see, for example, in this tower, if you see, there are lot of antennas, not one, there are many antennas are fitted in different directions. You can see each one seeing different direction. Please remember, here also not all of them working at the same frequency, number one. Number two, application wise also they are all not of a same application. Some may be point to point, some may be covering a sector, some may be covering certain larger range, shorter range, small zones. So, by looking at the tower you can't say this tower is working only at one frequency for one application, because tower is an asset to gain height, because the moment you want to cover larger area, wider area, then towers are very mandatory. Then this is a very interesting antenna. This is a very rare, very amazing sight. Just like people are always showing an interest to see aircrafts. Like that, is a very huge antenna, maybe running in the range of 20 to 30 meter diameter. Now the beauty is this is actually called dual reflector antenna. This is a very grand sight. If you happen to be very close to such antennas, your size will be nothing actually. This is called dual reflector, two reflector, one reflector that's called hyperbola, this is a parabola, and this hyperbola is at the focal point. This has got a very big story. In fact, it has got a technical word as a super Cassegrain antenna. We will see all such things when you come to microwave applications, and enormous motorized power required to even move this antenna in the form of changing the angle. The greatest advantage is very large gain. As I told you, when you go to microwave and above, the size of the antenna will decide the gain. Larger the size, bigger the dish, greater the reflected diameter, then the gain will be very huge. It may be in the range of hundreds of thousands, 10 power 5, 10 power 6 order. Such a very high gain antennas are required to make a deep space studies where you require a lot of focusing. It's a very interesting antenna. If some of you happen to see, you can really appreciate very huge structure. And it's another counterpart of that. See, that is one extreme, this is another extreme. This is also parabola. Recognize the parabolic shape. The shape is still parabola, but it is not full parabola. It is a section of a parabola. See, the idea of a parabola shape is to take the advantage of very large gain. The more the reflector resembles and follow a parabolic shape, the closer the accuracy of parabolic shape, larger will be the gain. This is a thumb rule you have to remember. Any parabolic dish antenna, if the parabola is made as close parabolic shape as possible, then the gain will be quite large. In any application, anyone will expect. But what happened, the other counterpart is, when you want to make a very big dish, as you see in the previous one, such a huge one, you see the money involved, the more the accuracy, the parabola shape. The parabola shape accuracy is very, very high accuracy. That's what's called surface tolerance, we call it as technically. And these dishes are costing maybe 50 lakhs, 70 lakhs like that. The size is bigger, accuracy, the machining capability is very, very high expected. So, the cost of such a professional reflector antennas, they are called professional reflector antennas, costing about 50 lakhs, only government can afford to do it. So, to compensate that, we also go for a very simple light weighted parabolic dish antennas, where parabola is not full shape, a small portion of the parabola. Whether the parabola is full shape or a part of the parabola, this is a full parabola. Okay, this is a full parabola, you can see it, no? This is called parabolic shape. If money available, need available, you can always go for a full parabolic shape. But otherwise, if so much of gain not necessary and the function also very little limited application, I will sectionize this. A section of the parabola can be taken, and that exactly what you are seeing. This is called very small aperture antenna, VSAT. Technically it is called VSAT, very small aperture antenna. This is part of the parabola, and this is used for all government applications, from state to state communication, from interstate, from maybe very rarely from larger distance coverage. All such things are used, and you can definitely see such antennas very frequently in all government buildings, private sectors, not at all costly, maybe less than 10 lakhs definitely, and it is a package, it's all related computer hardware all will come. And what is something very special about this antenna is it is foldable. Without much of manpower, you can simply fold it, pack it and move. So mobility is great, whereas mobility of the previous antenna is practically dangerous. It's not at all mobile, it requires enormous motorized power. So exactly opposite, purpose wise, use wise, cost wise, all opposite. These are all simple beauty. In fact, people who are showing some interest in antennas, they will appreciate, see how technology, we have to say hat off to technology. The technology helped us to move the antenna. I want antenna, I want big antenna, I want a high gain antenna, at the same time I want mobility also. I do not want to get locked in one place. So thereby latest defense antennas are coming to picture. You can see again a parabola. It is again a parabola, part of the parabola, and this is unfoldable. It is a defense application where time is very important and mobility is very important. You should unfold it, use it, fold it, run away. The demand, the requirements are quite large. So here you can see a parabolic, semi-parabolic dish antennas mounted on a jeep, the defense jeep. This another beauty is another antenna of a very high gain, again mounted on a tank, fighting tank. So now you can appreciate how much communication is very important, more in defense, more in fighting situations where people count time and mobility. And this is another simple beauty. This is another beauty where a ship become base for antenna. A moving ship, though we may imagine that ships are moving, mobility is questionable, but deep into sea, if you see, the ships are fairly immobile, and there are bases with all flexibility, that antenna is kept almost immobile, and whatever the mode, whether it is a ship mode or a road mode or rail mode or a air mode, communication is mandatory. Without communication nothing is there. So here is a ship communication, variety of antennas are there. That means in every profession a group of communication engineers always there with a great expertise, so that they will operate the system in a very short period to the deed. Now comes the latest technology. Now the technology is answering every time whenever a question is posed in the form of money, in the form of size, in the form of application, technology always giving an answer. Here you can see very small patch antennas. Now antenna size becoming very small, at the same time gain also reasonably maintained, mobility, and these antennas can be mounted in flush with the system. I want to fix an antenna on an aircraft surface, I cannot project it. I cannot project like this from an aircraft, it is not permitted. So I want in flush with the surface of the aircraft, and at the same time it should serve the purpose. So these are all called microstrip antennas, microstrip array of antennas, which is the latest answer from the antenna technology, and doing very well and working at a very high frequency in the range of gigahertz. Now we will come to a real starting point. We have seen variety of antennas in terms of frequencies, in terms of structure, in terms of economy, in terms of mobility, and in terms of applications. So all we have seen. Now I hope all of you will have a very broad picture what is an antenna, what it is made up of, really where is the crux of the problem, what is the simplicity, what is the real difficulty in the antenna. I think a very high, very broad pen picture everyone will have. And with that we should now enter into the antenna concept in detail. Now let us go back. The first antenna we said what is called Marconi antenna, or other is called the Hertzian antenna. So, what is an antenna? Let us recall one or two definitions so that that definition can be applied here. What is an antenna? Antenna is a conductor. What is an antenna? Antenna is a radiator. What is an antenna? Antenna is a transducer. What is an antenna? Antenna is a link between a transmitter and receiver in free space. But the most fundamental definition we take for current discussion is antenna is a conductor and it conducts electron. Antenna conducts electron. What is an electron? Electron is a packet of energy. So, when a conductor carries a current flow, okay, what is a current? Flow of charge. That means there is an accumulation of charge at one end, there is an accumulation of charge at other end, and when there is a situation, the charge flows. Now, try to understand. Now, we are introducing two things. A static accumulation of charge. This is the accumulation of charge. Here, charge is accumulated. So, there is a force. Charge is flowing, there is a force. So, you introduce two new terms, electric field, magnetic field. So, we are actually entering to the technical discussion because we called radio waves as electromagnetic waves, electromagnetic field. Thereby we said it is partly electric and partly magnetic. Now, this is really leading to the explanation how antenna radiates. Antenna is radiating. What it is radiating? Electromagnetic energy. This electromagnetic energy coming from where? From electron flow from inside the conductor. That means electron flow becomes origin. So, we should be very clear the link between electron flow inside the conductor and electromagnetic wave outside the conductor. Please, I repeat again, we have to be very clear about the link between electron flow inside a conductor and electromagnetic waves outside the conductor. That means the electron, wave, they are all interrelated. Electron is existing in a medium called conducting medium. Waves are existing in a free space. Try to understand the basics. Electron in a conducting medium on one side, waves in a free space, I can also say dielectric medium. So, there are two different mediums, but what is same? Energy inside, energy outside. Energy not really radiating or moving very fast, but here energy going to spread like a mega wave, super wave. So, how this transformation takes place, that we should be very strong. So, for that we are now going from the very basic, that the charge accumulation leads to electric field. Whenever there is a charge, most of you should have studied under the topic of electromagnetic waves or electrostatic or electromagnetic, all such topics every one of you would have studied. So, we are now recalling some of the basics from those topics, because without understanding of such topics we cannot go further, and you have to, if you are forgotten or if you are not remembering, please spend some time and go through such things. Definitely I will be touching upon these terminologies again and again, so that you should feel very homely with these terminologies. Whenever there is a charge is a source of force. These are the slogan you have to tell. Charge is a source of force. If there is a charge, the whole space surrounding the charge is called field. Field is a space where a force is experienced. Cricket field, football field, gravitational field, magnetic field, electrostatic field. The word field has got same meaning everywhere. Electric field because of charge is there. Magnetic field because current is there. Cricket field because a cricket match is played. Because a cricket match is in full swing, the whole space is experiencing a vibration. It experiences a vibration. Football field, football match is reaching the peak, climax. The whole ground is vibrating with enthusiasm. It is called football field. Gravitational field, the whole space surrounding the earth, feeling the pull, gravitational pull by virtue of mass. So, there is a vibration experienced by every particle above the earth, gravitational field. Electric charge, there is a vibration, there is a force, pulling, pushing force around the electric charge. It is called electrostatic field. There is a current. The current is a source of force, and the space surrounding the current feeling a vibration, attraction, repulsion. So, that is called magnetic field. So, whenever there is a natural source, there is a force. Just like sun radiating the sun rays exerting a force over the earth, we don't feel very explicitly, but the sun ray is an electromagnetic wave. It is experiencing, it is exerting a force. If you light a light, or if you make a heater, the heat radiations are there. It is making the surrounding vibrating. So, this you have to slowly visualize, experience, and this concept you have to use. So, here there is an accumulation of charge plus there is a accumulation of negative charge. So, in between space, it is a dielectric medium of space. This space is called electric field because electric force is experienced. Electric force is experienced. If you go to the previous one, there is a current flow. Surrounding the conductor, a force is experienced. So, how to show there is a force? We have to picturize. So, this circulating dotted line, what you are seeing circulating dotted line is an indication there is a force around the current carrying conductor. There is a force between the two accumulation of charge. So, whenever there is a charge, there is a force. Whenever there is a current flow, there is a force. I hope it is clear now. Now, you see a combination of both. Here you are seeing a transmission line, a wire carrying a current. So, a current is carried. When you say current, please understand they are all interrelated. They are not two independent quantities. If we say there is a current, it means there is a flow of charge. If there is a flow of charge, it says the flow of charge taking place from a place where there is a positive charge to the place where there is a negative charge. Flow itself says there is a gradient. Water is flowing from a higher altitude to lower altitude. Heat flows from a hot end to the cold end. So, whenever there is a gradient, there is a flow. So, if I say there is a charge flow, that means there are more charges, there are less charges. So, there is a flow of charge. So, the flow of charge itself an indication, a hidden indication that there is a flow of charge from a larger accumulation to the smaller accumulation, or from a positive charge to the negative charge. The moment charge flows, automatically it becomes current. When the moment current, then there will be additional force. Cause is same. The charge is the same charge, but on one part of the charge we are facing a electrostatic force. On the other part of the charge there is a current which is magnetostatic force. So, the electric force, magnetic force are the two counterparts of the same coin, electric force, magnetic force. I will indicate something else here. This is a simple beauty you can see. Whenever if there is such current flow, and as I told you, when the current flow are opposite in direction, I told you already, when the current flow is opposite in direction, there cannot be any radiation. That is a rule we said for an antenna radiation. For antenna to radiate, the current flow, for example, the same thing I showed you. Here there is one arm, there is a second arm. one arm, second arm, but these two arms are in line. So current flow will be either left to right or right to left, something like that. So same direction, that means this rod will radiate. This rod will radiate. On the other hand, suppose this rod is this way, this rod also this way. That means in both the direction, if you see current flow in one side left to right, other is right to left, then currents are opposite, so they will not radiate. Fine. So in this structure, this is what is called transmission line structure. Energy is confined. Energy is confined because current flow are opposite, they cannot get radiated. Okay. Now second point, if we say there is a positive charge and negative charge, the top wire carries a positive charge, the bottom wire carries negative charge, then the electric field always start from plus and end on minus, universal law. Electric field lines always start from plus and end on minus. There are certain laws, there are certain rules we are giving. This you try to understand and remember, because everywhere we cannot question the fundamental. Everywhere we cannot question the basic rules of a great scientist. What the scientist says, electric lines of force. These are all electric lines of force. Electric lines of force start from plus end on minus. So these lines are indication of force, and how the direction of force is a vector. So what is the direction of force? Always start from plus end on minus. So whenever there is accumulation of plus, accumulation of minus, in between there is a force. That force represented by arrows, lines. That's called lines of force. They are called lines of force. That what is written also, lines of force, indicating this phase is fully charged with force. Same way, when you say the current is flowing, the current gives rise to a flux. This current gives rise to magnetic lines of force. That is always having a rule, thumb rule, right hand Car's rule. So if you apply those Car's rules, the lines of force are cancelling outside, where the lines of force are adding inside, thereby the energy is confined. Please understand the terms. Energy we are telling. Suddenly how energy word comes, you can think, you can question. Now electron flow, current flow, magnetic flux lines, electric flux lines, all these terms are we are using, only emphasizing only one point. Whether it is electron flow or electron accumulation, again it is a energy form. Energy may be in potential form, energy may be in kinetic form. If electric charge is there, electron current also there, again energy is partly in electric form and partly in the magnetic form. So those are all very basics which you have studied in earlier semesters. So you have to recall those things. So here the energy is in the form of electric field, energy in the form of magnetic field. So there is a charge flow, there is a current flow, so the energy is carried by both of them. So what we want, the energy should be, in this particular case, energy is guided. We bring another term called guided. Energy is guided between the two wires. Energy should not escape, and that is what is happening. If it is an antenna, energy is not guided, energy is radiated. You see the two terminologies. Whenever currents are opposite nature, energy is guided, it is not escaping. Whenever it is not guided, energy is radiated. But in both the cases, electric field involved, magnetic field involved, energy flow involved, but end results are different. So this is a crucial point which one should know. Now if you observe this particular diagram, here it is a current flow indicated. The top one says the dot indicating current is coming out. The cross indicates current is going in. The same thing is repeated in different format, but both the thing what they are telling, the energy is confined between, energy is not escaping. So from the electrostatic charge point of view, the previous one, from the electrostatic charge point of view also energy is confined, here also energy confined, from the magnetostatic point of view also energy is confined. So both the diagrams telling the same point, whenever currents are opposite, please understand currents are opposite, here also current is opposite. Oh, whenever currents are opposite, energy is confined and guided. Whenever it is not same direction as you are seeing here, the energy is radiated. So, the point you should understand is, though the structure is same, in some portion currents are opposite, in some portion currents are same direction. Rule says current are opposite means no radiation, energy is confined. When currents are same direction, radiation, no guidance. So, anyone you one remember, you will appreciate the other. So, from today's discussion, we are now very clear, for radiation to take place, charge has to flow. The only condition is, if the flow is opposite direction, no radiation. If the flow is same direction, radiation is there. Again, what we said, again another point also, whenever the same structure may have both the portions, but based on the portion, in which portion current is opposite, which portion current is the same direction, based on that the job is different, this portion guiding, this portion radiation. There are other type of explanation also there to describe about the radiation, that we will see in different occasion. So, today we are very clear what is charge, what is electric charge, what is magnetic charge, what are the electric field, magnetic field, what is the meaning of field, what is the meaning of the field, and we also seen electric field, magnetic field always together, and both are interdependent and each generating each other. Here electric field, magnetic field are togetherness, they are together, they are two sides of the same coin. So, we are clear about the definition of fields, we are clear about there is a need of current flow for radiation to take place. So, we will continue the further explanation of why radiation is taking place in a conducting medium or in a conductor. That will lay a very strong foundation to describe antenna is a radiator. Thank you very much. We will see in the next lesson.